Let's solve some problems. Okay, first problem is find the perpendicular distance from a point, let's say 1 comma 3 comma 4, to the plane 2x minus y plus z plus 3 equal to 6. So many of these problems are just substitution into a formula. So if you don't remember the formula, forget it. So the distance would be AM is equal to magnitude of, because we are not interested in distances, can't be negative, AX1 plus BY1 plus CZ1 plus D divided by square root of A square plus B square plus C square. This is the formula. So let's just do the substitution. A is 2. So 2 times 1, this one, plus minus 1 times 3 plus 1 times 4 plus 3 divided by square root of A square, B square, C square. So 4 plus 1 plus 1, and the magnitude of this. So this would be 2 minus 3 plus 4 plus 3 by square root of 6. 3 cancels out. 6 by root 6. So this would be equal to 6 root 6 by root 6 times root 6, which is equal to 6 root 6 by 6, which is equal to root 6 units, because it's a distance. Okay, now let's look at the next problem. Find the length of the perpendicular from 0, 5, 1 to the plane passing through the points -2, 6, -6, -3, 10, -9, and finally -5, 0, -6. Okay, now given 3 points, we need to figure out the plane passing through these points. So let's think of a fourth one whose coordinates would be x, y, z. We know the equation of plane of such a plane is equal to the determinant of x minus 2, y minus 6, z minus 6, then minus 3 minus 2, 10 minus 6, minus 9 minus 6, and finally minus 5 minus 2, 0 minus 6, and minus 6 minus 6 equal to 0. Okay, now let's simplify it as one step. X plus 2, y minus 6, z plus 6, minus 3, minus 3 plus 2. This would be minus 1, 4, minus 3, minus 3, minus 6, 0 is equal to 0. Now let's solve this. X plus 2 times 0 minus 18 minus plus 18. So minus 18 minus y minus 6, 0 minus 9 plus z plus 6 plus 12 equal to 0. Okay, so we have minus 18x minus 36 plus this becomes 0, this becomes 0, so we have to multiply only with 9. So plus 9y minus 54 plus 12 plus 6 is 18, so 18z plus 18,6 is 108 equal to 0. Okay, now let's simplify this. Minus 18x plus 9y plus 18z plus 18 equal to 0. So we have minus 36 minus 54 plus 108. That gives us 18. Now let's take out minus 9 common out. So 2x minus y plus, no, not plus, minus into minus plus. So minus 2z minus 2 equal to 0. So the final equation, minus 9 gets cancelled out. 2x minus y minus 2z minus 2 equal to 0. Now that we have got the equation of the plane, we have to find the perpendicular distance from 0, 5, 1 to this plane. And we know perpendicular distance is 2 times 0 minus 1 times 5 minus 2 times 1 minus 2 divided by square root of 2 square 4, 1 square 1, 2 square is 4. Okay, now let's simply 0 minus 5 minus 2 minus 2 by square root of 9, which is equal to magnitude of minus 9 by root 9. That minus disappears if we take the absolute value. So 9 by root 9, root 9 by root 9. So that is 9 root 9 by 9, which is 3. I didn't have to follow this if we had just taken the root of 9 here itself. Okay, so 3 units, whatever it is. So sometimes what will happen, when you're solving this type of problems, you'll forget the question what is required. The moment you arrive at this, you will say, okay, I've got the equation of the plane. But actually, you're supposed to go further. Okay, now let's look at the third problem. Okay, find the length of the perpendicular from the point, let's say A minus 301 to the plane given by 4x minus 3y plus 2z is equal to 19. And not only that, we have to find the coordinates of the foot of the perpendicular. Yes, that is the point which touches the plane. Okay, now let an be equal to the length of the perpendicular from A to the plane. We know this is going to be 4 3 is 12, so minus 12 minus 0 plus 2 minus 19 if we bring 19 to the other side, divided by square root of 4 16 plus 9 plus 4. So this becomes minus 12 plus 2 is minus 10 minus 29 by square root of 16. This is again 29. First of all, we can get rid of the minus sign because of the absolute value. So that gives us 29 divided by square root of 29. If we rationalize it, we get square root of 29 units. So this is the perpendicular distance. Now we have to find the coordinates of the foot of the perpendicular. So let AN, no, not AN, let N be the foot of the perpendicular, right? So N is equal to some coordinate x1, y1, z1. We have to figure out these values of these. Now remember, perpendicular to the plane means what? It is normal to the plane. So direction ratios of AN are going to be the x1 minus 3, y1 minus 0. From where is this minus 3? All that is coming minus 3, 0, 1. That is A. The line is AN. Okay, so y1 minus 0, and the third is z1 minus 1. Here A is minus 3, 0, 1. Okay, now if you think about it, drs of AN will be proportional to the drs of the normal to the plane. That is nothing but the coefficients. So which implies x1 plus 3 by y4 is equal to y1 by minus 3 is equal to z1 minus 1 by 2 is equal to, let's say, the symbol we use is lambda. So now each one of them will take one by one. x1 plus 3 by 4 equal to lambda, which implies x1 plus 3 equal to 4 lambda. x1 is equal to 4 lambda minus 3. Okay. y1 by 3 minus, let's take it up, is equal to lambda, which implies y1 is equal to minus 3 lambda. Okay. z1 minus 1 is equal to divided by 2 is equal to lambda. So which implies z1 is equal to 2 lambda plus 1. And remember, this is the coordinates of the foot of the this one. So 4 lambda minus 3 lambda and 2 lambda plus 1. This lies on the plane, right? The foot of the perpendicular. So which means it should satisfy the equation of the plane if we substitute it, right? So since this lies on the plane, let's substitute it. 4x1 minus 3y1 plus 2z1 equal to 19. This is the plane. So which implies 4 times 4 lambda minus 3 times minus 3 lambda plus 2 times 2 lambda plus 1 is equal to 19. Of course, 16 lambda minus 12 plus 9 lambda plus 4 lambda plus 2 minus 19 equal to 0. 16 lambda, 9 lambda, 4 lambda. So this gives us 16 plus 4, 20 plus 9, 29 lambda. Minus 12 plus 2 gives us minus 10. Minus 10 minus 19 is minus 29 equal to 0, which implies 29 lambda is equal to 29, which implies lambda equal to 1. So the coordinates of the foot of the perpendicular would be what? Remember, that is x1, y1, z1, which is equal to 4 lambda minus 3, comma minus 3 lambda, comma 2 lambda plus 1. Now, since we know lambda is 1, we can write it as 4 ones 4 minus 3 is 1. Lambda is 1, so minus 3, 2 plus 1, 3. 1 minus 3, 3 is the foot of the coordinates of the foot of the perpendicular from the given point. Okay, and by the way, in general, if we generalize the process that we followed, in general, the foot of the perpendicular is given by x2 minus x1 by a is equal to y2 minus y1 by b is equal to z2 minus z1 by c equal to minus ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square. So this is the formula. Now here uh, x2 y2 z2, this is the foot of the perpendicular. x1 y1 z1 is the point away from the plane, and ax plus by plus cz plus d equal to 0 is the plane. Let's look at the next problem, fourth one. Now let's say the problem says find the image of the point A, let's say that is located at minus 301, and the plane in the plane 4x minus 3y plus 2z is equal to 19. You know, I'm using the same plane which was there here, right? 4x1 minus 3y plus 2z, primarily to avoid repeating steps. Okay, so now what we need to find is the image. Now what's an image? If this is your plane and if this is the point, then right, this is your foot of the perpendicular of this. So if this is A, we have to find the image. That means on the opposite side of the plane, equidistant. That's called the image. Now, as we have seen in the previous problem, let's say AN is the perpendicular distance from um, A to the plane. Okay, so we have seen the foot of the coordinates of the foot of the um, perpendicular is 1 minus 3, 3 is the foot of the perpendicular. Okay, so let's say this is N. Now let B be the image of the point A in the plane. So this is B. Now remember, A and B are equidistant. So which implies that N is the midpoint of AB. We know the formula for midpoint. So 1 minus 3, 3 is equal to x2 minus 3 by 2, y2 plus 0 by 2, z2 plus 1 by 2. So let's coordinate. Yes. So x2 minus 3 by 2 equal to 1, which implies x2 minus 3 equal to 2, which implies x2 is equal to 5. Okay. Similarly, y2 by 2 is equal to minus 3, which implies y2 is equal to minus 6. z2 plus 1 by 2 is equal to 3, which implies z2 plus 1 is equal to 6, which implies z2 is equal to 5. So therefore, coordinates of P is equal to 5 minus 6, 5. This was in case of a specific thing. In general, if we have to figure out the image, in general, formula for the image is equal to x2 minus x1 by A is equal to y2 minus y1 by B is equal to z2 minus z1 by c is equal to minus 2 ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square. Yes, here image is equal to x2 y2 z2. The given point is equal to x1 y1 z1 and the plane is ax plus by plus cz plus d equal to 0. So that's it. Bye.